So, the fundamental counting principle, okay? When there are m ways to do one thing and n ways to do another, there are m by n ways of doing both, okay? The best way to explain this is by looking at an example, okay? So take a look at this first example. You have 3 shirts and 4 pants. That means that there are 3 times 4 possibilities. So there's 12 different outfits you can have. Guys, we are going to draw this one out, okay? I want you to write shirts, shirts, shirts. We have 1, 2, 3 shirts. And how many pants do we have?
4.
So put pants 1, pants 2, pants 3, and pants 4. Use a different color. Shirt 1 can go with how many of the pants? All 4 of them, right? So shirt 1 can go here, go here, go here, and go here. Do you guys agree? How many possibilities is that? 4. There's 4 combinations there, right? Shirt number 2 can go with pant 1, pant 2, pant 3, and pant 4, right? That's a whole new 4 different possibilities. Do you guys agree? And then shirt 3 has how many possibilities? 4. It can go to pant 1, pant 2, pant 3, or pant 4. So there's 4. So altogether, how many possibilities were there? 4 plus 4 plus 4 gives me 12. Do you guys see how that works? You're taking the number of possibilities from one example or one particular event, and you're multiplying it by the number of possibilities in the other event, okay? So there were 3 different shirts and 4 different pants, so we have 3 times 4 possibilities. All right, if there were 6 flavors of ice cream and 3 different cones, you would take 6, multiply it by 3, and you would get how many possible outcomes? 18, okay? Okay. Now, before we jump into permutations and combinations, okay, we need to talk about something called factorial. For any positive integer n, the product of the integers from 1 to n is called n factorial and is written n exclamation point, okay? N exclamation point. N exclamation point is equal to n times n minus 1 times n minus 2 all the way down to 1, okay? So let's say we had 5 factorial, okay? 5 factorial, we would start with 5, multiply it by 5 minus 1. What's 5 minus 1? 4. Then we would multiply it by 5 minus 2, which is 3. Then we would multiply it by 5 minus 3, which is 2. And then we would multiply it by 1. Okay? You stop when you get to 1. So, what's 5 times 4? 20. And then 3 times 2? 6. And then times 1. So 20 times 6. So 5 factorial is the same as 120. Let's do one more to make sure we got it. Let's say we had 6 factorial. Okay? What would 6 factorial be, writing it all out?
6 times 5 times 4 times 3 times 1.
Very good. Times 2 times 1. I think you missed the 2, Emma. Okay. So we take, well, we already know what 5 factorial is, right? So can we just say 6 times, what was 5 factorial? 120. And 6 times 120 should give me like 720? Someone double check me on that.
Yeah.
That's right? Okay. Now, the only one that's a little weird is 0 factorial. Now, normally we think 0 factorial, it should be 0 times nothing, right? 0 factorial is weird. It's always equal to 1. There's no shortcut around that. You just have to memorize that, okay? 0 factorial is always equal to 1, not 0. Got it?
Exclamation point, right?
Yes, that is an exclamation point, okay? It's not shouting at you, okay? It's just a factorial. Okay, questions so far on factorials? Now, the reason they're important is it's because in permutations, our definition is defined by this factorial, okay? So a permutation is an arrangement of objects in which order is not important, okay? Is important. So order matters. It matters. Okay? The number of permutations of n objects is given by n capital P n equals n factorial. The number of permutations of n objects taken r at a time, where r is less than or equal to n, is given by n capital P r equals n factorial over n minus r factorial. Okay? Now, what I want you guys to write is this is just a fancy notation. Okay? N is going to be our total. And r is going to be the number of choices. Okay? Now, again, these are permutations. This is when order matters. When the order of what we're choosing makes a difference. Okay? When order matters. Okay, let's do one really quick example. Let's say we had 3P2. So right now we're saying that we have 3 total choices with a permutation. We're only picking 2 of them, okay? So we would say that this is equal to, remember, this was our n value. So we're going to take the n value and write it as a factorial. So it'll be 3 factorial over, and this is my r value. It's n, which is 3, minus my r value, which is 2 factorial. So this is going to be 3 factorial over 3 minus 2 gives me 1 factorial. How can I rewrite 3 factorial broken down? Xavier? Yeah, 3 times 2 times 1. And 1 factorial is just 1. So this is going to be 6 divided by 1, which is just 6.
This is just a question.
Yep.
Isn't it in the 3 and the 2 next to the P, don't they also multiply to 6?
They do, but that's not going to work every time.
Okay.
Good observation, though. Did you guys hear what Sophia said? She said, so when we looked at the original problem, do you see how there's a 3 and a 2 next to the P? She asked, can we just multiply those together and get the final answer? It only works in this case, okay? It's not a consistent theme, okay? All right, let's see another one. So, in how many ways can you arrange the letters in the word mouse, okay? In how many ways can you arrange the letters in the word mouse, okay? First thing we need to ask ourselves, does the order matter?
Yeah.
Yes. So when order matters, it's always going to be permutation. Okay? So write a P. So we need P. How many total letters are there to pick from? 1, 2, 3, 4, 5. How many of those letters are we going to be using?
5.
We're going to be using 5. So it's 5 permutated 5 times. Okay? Because there's 5 total letters. Let's write that in there for this one. Total letters. And we're picking how many of them?
5.
We're picking 5 of them, right? So we're going to write it. It's going to be n, which is that first number. So we're going to take the 5 and we're going to write 5 factorial over n minus r. What's n minus r here?
5 minus
5 minus 5 factorial. This is where you have to be very, very careful, okay? 5 factorial, you agree is going to be 5 times 4 times 3 times 2 times 1 over what?
1.
No. Oh, yes, you guys are right. It's 0 factorial, which simplifies to 1. So this is going to be 5 times 4 times 3 times 2 times 1 all over 1. Very good. And we already found 5 factorial. What was it? So it was 120. So there are 120 permutations. So it can be arranged. Very good. 120 different ways. Yes, Giselle. Very good. Now, we're going to get into probability, how this affects probability. But remember when we were calculating like all the different, like the sample space? What are all the different combinations? In some instances where you're given a fixed number of letters to use in a bunch of different ways, this is how you calculate. These are called permutations where the order matters. Okay? All right. B, in how many ways can you arrange 3 of the letters in the word orange? Okay? 3 of the letters in the word orange. Let's count the number of letters. How many letters do we have to pick from? 1, 2, 3, 4, 5, 6. So we have 6 permutated. How many are we picking? 3. Do you guys see how we're writing this? Guys, the right-hand number should always be less than the one on the left. Are we Gucci with that?
Or equal to, right?
Or equal to. Yes. Thank you. So we're going to write 6 factorial. That's just my n value. Factorial over what? 6 minus 3 factorial. Okay? So this is going to be 6 factorial over 3 factorial. Now, write it out because a lot is going to cancel, okay? 6 factorial, do you guys agree, is 6 times 5 times 4 times 3 times 2 times 1? And 3 factorial is what? 3 times 2 times 1? Yeah?
What if it was like 10? So it'd go 10 times 9 times 8 times 7 times
Yep,
6.
all the way down to 1.
So what if we get 100 or something?
That's why we have a calculator. Okay? All right, so check out what's going to happen. What can I cancel out before I multiply? Christian? The 3, the 2, and the 1. Okay? So we just have 6 times 5 times 4. Well, 6 times 5 is 30. Times 4 gives me what? 120. So there were 120 ways as well for this one. Now, this can sometimes get a little bit confusing. So can I show you guys, this is the proper mathematical way to do it. Can I show you Mr. Yurko's way? Okay, so Mr. Yurko's way is, do you see how this says 3? Draw, guys, please write this down. Even if you don't use it, please write this down. Draw 3 spots. 3 different choices, right? Then start with this number, the 6, multiply it by 5, and multiply it by 4. So the second number, your R number, is going to be the number of blanks that you draw, okay? And then this number is going to tell you, okay, do 6 times 5 times 4. Go down until you're done. You've completed all the spaces. Isn't that what we just did exactly? It was 6 times 5 times 4?
Yeah.
Okay? So this is how I do it, and you're going to get 120 also.
So now you don't have to multiply all.
You don't have to do all the canceling out and all that stuff. Yeah.
So even though it's easier to cancel out, do you have to, like, say on the test?
No, you do not. You could do 6 times 5 times 4 times 3 times 2 times 1. And there's a button I'm going to show you on your calculator to actually do factorial if you're using a scientific calculator. And then you can do divided by, and then you can either do 6 or do 3 times 2 times 1. Okay? Yes. Yes. Good questions. Any other questions? Okay. Let's do another one. Your band has written 12 songs and plans to record 9 of them for a CD. In how many ways can you arrange the songs in the CD? What's the first question we ask ourselves, people? Does the order matter? Is the order going to matter here?
No.
What?
Yes. I don't know.
In how many ways can you arrange the songs in the CD?
Yes, because it's asking how you arrange it.
Yes, order definitely matters. Okay? Whenever you see like the words arrange, organize, finish, like how did they finish? Like if it's a race, how did people finish? The order is going to matter, right? So in this case, yes, the order matters. The order totally matters when someone's creating an album, okay? All right, so if the order matters, we know we're going to be using a capital P, okay? How many total songs are there to pick from? 12. How many are we picking? 9. So we can do it the math way, which is 12 factorial over 12 minus 9 factorial, which is going to be 12 factorial over 3 factorial. You're going to have to use a calculator for this one. This one's way too hard. Do not use a calculator. Okay? Now, what I want you guys to do is look for that factorial symbol in your calculator. Okay? It should be an exclamation point. You probably need to use either the second or the alpha function. So we should have gotten 12 factorial, which was 479,001,600. We're dividing that by what? 6, because 3 factorial is 6. When you divide it by 6, you're going to get 79,833,600. A lot of possibilities, right? Now, if you wanted to use Mr. Yurko's way, how many blanks would I draw? 9 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I would fill in from 12, 11, 10, 9, 8, 7, 6, 5, and 4. And I would multiply all of these. If you multiply all those in your calculator, you should get the same 79,833,600. So there's a lot of choices when people are making these CDs, I guess. For a town parade, you will ride on a float with your soccer team. There are 14 floats in the parade, and their order is chosen at random. Find the probability that your float is first, and the float with the school chorus is second, okay? This one is a probability question, okay? Find the probability that your float is first, and the float with the school chorus is second, okay? So remember, probability is the number of favorable outcomes over what? Over the total. Total number of outcomes. Okay, so the number of favorable outcomes here, okay? How we figure that out is it said that the probability that your float is first and the probability that the school chorus is second, okay? Let's save that for the second part. What's the total number of outcomes, okay? Well, we would have to set up a permutation. There's 14 possible floats, right? And we're organizing them how many ways? Are we leaving any of the floats out? No. So we're organizing them 14 possible ways. So we have to do 14 factorial, which is, in our calculators, let's do it. 14 math probability Enter. Oof. 8, 7, 1, 7, 8, 2, 9, 1, 2. So, hold on. You guys, this part down below, okay, whenever you see this in your calculator, this means it's in scientific notation. This E is times 10, and then this is your exponent to the 10th power. So you're going to move your decimal place 10 units. So we're going to move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to add 2 zeros, and this is our answer, okay? So 87,178,291,200. Okay, so that's the total number of outcomes. That's our denominator. Now, we have to find the number of favorable outcomes, okay? How we figure that out is we have to do, okay, well, we know that we want 2 of the events to already happen. So we need our float to be first, right? And then we need the school chorus float to be second. Do you guys agree? These have to be first and second. Then we have how many floats after that to choose from? We have 12 floats that can be permutated how many different ways? 12 different ways. In other words, that's 12 factorial. Do you guys agree? So we're going to end up getting 12 times 11 times 10 times 9. So if you plug that into your calculator, that's 12 factorial. We did it for the last problem. It was 479,001,600. So this is going to be 479,001,600 divided by 87,178,291,200. 178, 291, 200. .0.00549, which is approximately 0.549%. Now, this gets very complicated when the numbers are this large, right? Let's keep everything in terms of factorial and see if it makes it any simpler. So we said that the probability, right, was 12 permutated 12 times over 14 permutated 14 times, right?
Wait, question.
Yep.
Where did you get 12 from?
Where did I get 12 from?
Yeah.
So it said that our float needed to finish first, right? And the school chorus float needed to finish second. So we're only dealing with the 12 floats after that, right? And those 12 floats can be organized 12, we're going to pick 12 of them, right? Yeah. So the permutations would be 12 permutated 12. Okay? So you guys agree this was 12 factorial over 14 factorial, yes? Yeah. 12 factorial is going to cancel with 14 factorial because this is going to be 12 times 11 times 10, so on. And this is going to be over 14 times 13 times 12 times 11. Do you guys agree? After 12, everything's going to cancel? So we really only have 1 over 14 times 13. And we get the same answer if you do it. It's 0.549 No. 0.00549. Which is 0.549%. Guys, I do not care which way you do it. If you like dealing with the really large numbers, if you like leaving it in terms of factorial, okay? But you should have gotten 0.549%. Yeah. Arrange all of the letters of the word boundary and then 3 of the letters of the word, okay? So boundary has how many letters in total? So there's 8. So we're going to do 8 total permutated. The first example is going to be 8 times. Do you guys agree? Because we're going to arrange all of the letters, right? All of the letters. So it's 8 permutated 8. That's just going to be 8 factorial. Plugging that into your calculator. You should get 40,320. Okay? Then if we do 8 permutated 3 times, you would do 8 factorial over 5 factorial, because 8 minus 3 gives me 5. You would get 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1.
Can you please send over Mr. Gutsky's attendance?
Yes. 5 times 4 times 3 times 2 times 1. So these 5s will cancel, the 4s will cancel, the 3s will cancel, the 2s will cancel, and the 1s will cancel. So we have 8 times 7 times 6. Plug it into your calculator. Gives me 336. All right, I want you guys to try 2 and 3, and then we'll talk about it. Okay, so for number 2, you should have gotten 6 factorial over 3 factorial, which would have given you 6 times 5 times 4. And this one should have gotten you 120. For 14 permutated 9 times, you should have gotten 14 factorial over 5 factorial. This would have given you 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. 14 factorial divided by 5 factorial. This one should have given you 726,485,760. And the last one, there are 8 students auditioning for the main role in a school play. The order of the student auditions is chosen at random. Find the probability that you are chosen first to audition and your friend Petra is chosen second, okay? So again, this is an example where we know what the first one should be and we know what we want the second one to be. So our total is going to be 8 permutated 8 times because there's 8 students to pick from. You can arrange them any way. That's the total number. But on the top, it's going to be 6 permutated 6 times. Because we only have 6 students after you know what you and your friend want to audition first and second. And so this would be 6 factorial over 8 factorial. Everything's going to cancel from the denominator. 6 times 5 times 4 times 3 times 2 times 1 over 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Everything goes away except for the 8 and the 7. This gives you 1 divided by 8 times 7. 0.179. which is 17.9%. Yeah, Christina.
For the last one, did you put 5? Because I got a different answer to the third question. It's 9.
For the, which one? The very last one?
No, the third one, which is evaluate 14.
Can we submit?
You put 5. Yeah, did we submit?
It should have been 5 because it was 14 minus 9 on the denominator,
Oh.
which should have been 5. Does that help?
Wait, which is the one?
Xavier.
For the last one, I got 0.0179.
Yeah, that's what I got too.
Me too. I wrote that wrong. So it should be what? 1.79%? Yeah. Sorry guys. Erase that. It was 1.79. Thank you, Xavier and Emma. Yes, submit these. Okay? Tomorrow we will talk about combinations. Okay? Combinations are different. So in permutations, order mattered. In combinations, guess what doesn't matter? The order. Okay? All right.